Okay, now we're gonna find the integral of the arctangent between 0 and infinity. One quick way to see that this value is infinite is just by drawing the graph of the arctangent. So now that the arctangent is defined between for every it is defined for the whole real number, but its range is between minus pi over 2 and pi over 2. But we are interested only in the positive value. So here we see that the area, so let's have this one as t, so the area as c increases goes to infinity is gonna be infinity. So it's gonna be infinite. So this area here, so that's like this area of this strip that has length infinity and width pi over 2 is infinite. Okay, it's almost pi over 2 except for this one here. So this is a quick way of saying that this one is infinity. Okay, another way to do this is by using the comparison theorem. So we have proved in one of the videos that the arctangent of x is between x over 1 plus x squared and x for all x positive numbers. Okay, now we can integrate between 0 and t, 0 and t, 0 and t, and we are interested in this one here, so let's call it g of t. Okay, so it's gonna be 0 to t of x over 1 plus x squared dx. So this is the 1/2 the log of 1 plus x squared between 0 and t, and when we plug the value we get 1 plus t squared minus the ln of 1, which is 0, so g of t here. So now we take the limit, okay, limit as t goes to infinity, the limit as t goes to infinity, which is going to be infinity because the log of t squared goes to infinity as t goes to infinity. That means that the limit is infinite. We use the fact that if you have two functions that are positive, and if the integral of this one is infinite, that means it's the same, it's divergent, it has infinity. So our g now is this I that we're interested in, and our f is just x over 1 plus x squared. And in fact, we show that it's plus infinity. Okay, there is another way we can use the integration by part. Okay, we can use integration by part to find that between 0 and t of arctangent x dx is just x arctangent of x between 0 and t minus x over 1 plus x squared dx between 0 and t. Okay, so we can solve this one by using the famous rule that's u prime times v is uv minus uv prime. Our u prime is 1, therefore our u is x, and our v is arctangent here between 0 and t, and u is x, and the derivative of arctangent is 1 over x squared. When we compute this, okay, so we get two values. Okay, we get t arctangent t minus 1 over 2 ln of 1 plus t squared. And when we do that, we take the limit. Okay, so here we take the limit when t goes to infinity. The only issue that we have is that this is infinity and this is infinity. So we need to get rid of this issue. Okay? So what we do is we just divide here by t squared. And we see that this one is 0 and this one is infinity, that means the limit is infinity, and therefore this integral is divergent or accepts infinity or infinite. So this is like 3 ways, quick proofs of the fact that this integral is infinite.